Hi, welcome to Nomis Academy. In this video, we are going to be looking at tangent theorem, and then we are going to consider theorem 3. Now, in the previous video, we looked at theorem 1 and 2, and we also solved problem under those theorems. But in this theorem, we are going to state theorem 3 and also show the proof. Now, let's state theorem 3. It says that the angle between a chord and the tangent of a cycle is equal to the angle in the alternate segments. Okay, so this is the theorem. It says that the angle between a chord and the tangent of a cycle is equal to the angle in the alternate segments. Another name for this theory is called alternate segment theorem. So now let's take the diagram to see clearly what we are just defining. So we have a cycle. Okay, let me draw it very well. Okay. So this is the center of the cycle, center O. Now if we have a tangent at this point, we call the point P. Okay, let's call this a tangent at point P, and then a chord. We call this point Q, and then another point which is called the angle at the opposite or the other segment, we call here R. Now the theorem says that angle at this point, which is the angle between the chord called PQ and the tangent, let's call here PT, this particular angle is equal to the angle in the other or in the alternate segments. So these two angles are equal. So we are going to prove the theorem. We are going to show that the angle at P is equal to angle at R. So now let's start. We are given a cycle PQR with center O and tangent PT. Okay, so we have a cycle PQR, center at O, and then a tangent PT. All right, so let's continue. We are to prove that. We are going to show that PRQ, that is angle at R, is equal to QPT, that is QPT, this particular angle. So we are going to be showing that these two angles are equal. Now construction, we are going to draw a diameter that passes through O and then meet at another point. Draw a diameter PO to meet at M. Okay, to meet at M. So we call here M. And then we are going to join M to Q. Join MQ. Okay, so we have MQ. All right, so we've done that. So this is a construction. The next thing to do is to start the proof. Okay, to start the proof. So first thing we need to consider is the angle PRQ. PRQ is equal to angle at M. So let's call this M. Okay, this is M. This is capital M, while this is small m. So we use capital M here. So this is small m. And then we can also call this side N. Call here R. Okay, I hope you can see that. And then we can also call here small letter P. Okay, we can call that small letter P. Okay, now let's proceed. So PRQ is equal to M. Is equal to M. So meaning that they are equal, or we can say, let's use the real angle name PMQ. Okay, they are the same thing, so we can call it M. They are equal. And what's the idea behind this? Angles in the same segments. Angles in the same segments. Okay, so meaning that angle at R and angle at M are in the same segment and they are equal. Okay, let's proceed. Since they are equal, we also note that angle, okay, let's use the conventional sign, angle MQP is equal to 90 degrees. Okay, is equal to 90 degrees, which is angle in a semicircle. Okay, so we agree with that. All right, so if MQP is 90 degrees, then NR is also angle at N plus angle at R is 90 degrees. Okay, understood. All right, so let's proceed. If this particular angle is 90, then it means angle M plus angle P is 90 degrees, which is the remaining side or remaining angle. Remaining angles. The remaining angles of the triangle PMQ. Okay, now let's proceed. And remember we state that PRQ is M. So let's proceed. If it is M, then we can just write, in place of M here, we can say PRQ, which is M, then plus angle at P is 90 degrees. So I'm going to call this equation 1. I'm going to call that equation 1. Now, also, you can see that this angle P plus this sum up to 90 degrees. And what's the reason behind that? It means that NP is perpendicular to PT. It writes P plus angle QPT is equal to 90 degrees. And the idea behind that is that OP is perpendicular to PT. Okay, so that's the reason behind that. So let's clean the other side of the board. So I can now take it as equation 2. So I can say angle at P plus QPT is 90 degrees. Equation 2. So equate the two together. Equate equation 1 and 2. Okay, let's equate the two together. So I can now say that since equation 1 is this, since this is equal to 90 and this is also equal to 90, then the two are equal. The two are equal, so we can say PRQ plus angle at P is equal to angle at P plus QPT. So you can see that. So you see that angle at P cancels each other. This cancels this. So we are left with PRQ, which is equal to QPT. Okay, so you can now see that this angle R, is equal to angle at P, hence proved. So we've come to the end of the proof. So this is it. You can see that according to Theorem 3, it says that the angle between the tangent and the chord of a cycle is equal to the angle in the alternate segment. So thank you for watching. See you next time. Bye.